Welcome to the stream, the Land Tamer stream tonight. It is Friday night, and I've had dinner, but it's time to do a little grinding on some labs. I got 2 labs left in the generic, kind of basic, pre-dynamic routing protocol section. Excuse me, continuing with GRE and keepalives, and then I'm going to work in an ODR, basic ODR configuration, which is really cool. I didn't really know anything about ODR. I've never configured it even in a lab, and it sounds like it has some really cool use cases. The fact that it relies on CDP is really cool. So looking forward to that one actually, and playing around and seeing kind of what that looks like in a running configuration. But first of all, GRE keepalives, and it's interesting. I was kind of on a rant yesterday a little bit about using a backup interface on a GRE tunnel interface, and how wrought with problems that is, because your GRE tunnel interface has no idea of what's going on with the other interface, and it's going to stay up. And I was doing some reading as well today on GRE tunnel interfaces and some of their deficiencies, and one of them is just that, not having really the tunnel interface is going to be up, unlike, for example, an IPsec tunnel, a LAN-to-LAN IPsec tunnel. A GRE tunnel interface will stay up even if the other side is down, and that can create a black hole issue with packets getting dropped. So this GRE keepalive it has limitations on when it can be used and how it can be used, but looks like everything I was ranting about, this is kind of the answer for it. So I'm kind of excited about that. So I'm also excited that I have my new, I've changed my colors. I know it's simple stuff, but I changed the colors on my iTerm profiles. And now I've got my default profile is Star Wars closing credits, which I'm way pumped beyond more than I even should be. But anyway, moving on to this GRE keepalives. The first part of this is pretty much all the same as yesterday. And then at the end, we have a backup interface and the keepalive setup, which I've done my research on. So hopefully this will go smooth. We're going to be working between routers 4 and 5 segments. And let's go ahead and build it. So I'm going to switch to router 4. Already logged in. It's mustard. Now router 4 is mustard. Router 5 is, I don't even know what that color is. Don't know I know about 4 color names. Magenta maybe? I have no idea. It's purple. But anyway, router 4 and 5 we're going to create our tunnels just like yesterday. Interface tunnel 45. We're going to say tunnel mode GRE IP. And IP address 1.5.45.0.4. Tunnel source is on the VLAN. Need to make sure I get these right this time. On the VLAN 45 link, so that's going to be tunnel source 155.1.45.4, and tunnel destination is going to be 155.1.45.5. Now that, of course, is going to be reachable, so tunnel should come up, and it does. And I'm doing the same on 5. And I should be getting into the habit of typing into my text editor first, then pasting. We'll do that on the next one. I've already started this one, and really I did all the same configuration yesterday except for the last requirement here. So interface tunnel 45, I'm going to do these one by one so I don't get them confused. And we're going to say tunnel mode GRE IP, tunnel, IP address 155.45.0.5, and tunnel source is 155.1.45.5 tunnel destination. And I'm typing all these out to where most of them anyway, the commands, so that'll help stick. All right, so we got tunnel 45 built. Now let's do tunnel 100. Tunnel mode GRE IP address 15100.0.4, and tunnel source. This VLAN 100 link, and this is where I went wrong yesterday, because it is not these. I need to make a new box for VLAN 100, because that DMVPN is 169.254.100.4 tunnel destination. It's interesting too, we're doing a tunnel. Let me just make sure. Do show run interface GI0. No. Do show IP interface brief. Yeah, the actually Ethernet segment is it strays from this box. It's actually 169.254. So tunnel source. I already did that. Tunnel destination. This is where I really screwed up yesterday. Alright, so interface tunnel 100, tunnel mode GRE IP, tunnel or IP address 15100.0.5, tunnel source, and tunnel destination. All right, and that should be up as well. Ping, let's see if I can ping the other tunnel interface 5.100.0.4, and I can. And what's the other one? Ping 15100.0.4. Yeah, so we can ping across the tunnels, or through the tunnels, I should say. And tunnels are up, so now we want to create some static routes. And this is the traffic that we're going to test the failover and the keepalives on. And that is the loopback 0. So on router 4, it's actually asking me for 2 static routes because we're going to be testing this path and that path, right? And the backup interface and keepalive function. So I'm going to do IP route. And in this case is 150.1.5.5/32, and the next hop here is going to be, all right, we're going to have 2 routes. One is via DMVPN link. That's going to have a higher administrative distance. And the other is going to be via tunnel 45. Okay, in other words, this is another way of saying tunnel 100. Yes, we're going to have 2 static routes, one using tunnel 100, the other using tunnel 45. And the one on tunnel 100 is going to have a higher administrative distance because we want it to be lower priority. No, that's wrong. Tunnel 45 is going to be the backup interface for tunnel 100. So we want this to have a higher AD. Let me check my lab key here. Static routes should have a higher than those. Yeah, for both the DMVPN cloud and tunnel 45. Because what we're going to do here it says DMVPN cloud, but I'm assuming that is talking about tunnel 100. which we just built. So that's going to be, and that is going to be, should have a higher administrative distance than those on tunnel 45. Okay, I'm a little confused about that. Static routes. Configure IPv4 static routes via both DMVPN Cloud and Tunnel 45. The static routes in R4 and R5. One 5105. Where is that? Tunnel 0. So they're wanting me to create a static route. All right, well, I will follow along here. So we have on this cloud, we have physical interface. Okay, I see what the issue is. So it wants me to use the VLAN 100 Ethernet link. What it's really saying is it wants this to be via not just the physical link, but via this other tunnel, tunnel 100. So I almost have a tunnel. I'm creating a tunnel over a tunnel. From 100 to 0. No. All right, that's a little confusing, but essentially what I'm supposed to do, when it says DMVPN, it is saying that it wants this to be higher AD. All right. But when we configure this as the backup interface, that tunnel is going interface will go down. Yeah, that tunnel interface will shut down. We've got two tunnels here. And then if this interface goes down, traffic will route through it then. Which is interesting that you would do a static route with the higher administrative distance on the DMVPN link because, oh, I see why. I guess I can see this logic. So the logic is We would use tunnel 45 first if it's up, but we're normally going to have it down. But if for some reason it comes up, then that will always take priority in our static route. Which is confusing because if this goes down, that static route's going to be invalid anyway, so I don't get why we changed the distance there. Well, let's try both ways and see. So IP route 151, and this is going to be via the DMVPN link. Yeah, because if I go over here, show this is tunnel 0. 155.1.0.5 is the DMVPN. 0.5, correct, and that is going to be a higher AD. So the IP route 150.1.5. I was not doing what it told me to do because it didn't make sense. But I just need to do what the requirement is telling me to do. And in fact, that's a good point to make in preparing for the real world lab, because really, despite what I think I need to do with the instructions say, right? We're going to do tunnel 45 here. Same on router 5. 150.1.4.4. Excuse me. That's going to be via 150.1.0.4. And actually, that should have the higher AD. Yeah. Do show static route. Do show IP static route. Yeah, so this has an AD of 1 via tunnel 45. So we're doing what they're telling us to do. Now here's the real meat of the lab right here. So router 4. By the way, let's make sure. Yeah, trace route. Okay, it's going via tunnel 45. That's right. However, so this is our backup interface. I'm going to do that on both. And we're going to do the keep alive. So I've already closed that document. Yeah, I think we're just going to do, it's not asking us to change the values here. So keep alive. Wait, interface tunnel 100. Yeah, we're just going to go with the defaults. All right, so show tunnel 100. Hardware is tunnel. Backup interface tunnel 45, failure delay 0 second. Keep alive set, retries 3. That's a default. Tunnel source, tunnel destination. So show interface T45 down, as we would expect. Now here it's in standby mode. It's interesting. Now in the first line says tunnel is up, but here it says right away tunnel is, it doesn't say it's up. It says it's in standby mode, the line protocol is down. So that's interesting. Keep alive is not set here. There's, yeah. Okay. So we've done our configuration. I think our configuration is correct. Show IP static route. Okay, so now it says that both of these are not active. Show IP route static. Ah, so that is a problem. So we don't have a route. So that's why it does not make sense to me. So what's happened is because this is a higher administrative distance, the lower AD takes precedence. That's not how floating route, okay, yeah. That's not how floating route should work though. Why is this route not in the routing table? See, it's the way I would think this should be done. this link is up. Why is this not in the routing table? All right, show backup command. That's new for me. Primary interface, secondary interface. That's cool too. You can see this is down standby mode. What if we change this route here? So what if I take this one out? Now it's there. Okay, now this is saying I need to have it. Okay, that's... Now for some reason, if I left this as AD of 0, the default, this route did not go into the table. Even though that interface is down. Okay, I'm going to have to research why that is the case. Let's go to router 5. Yeah, that's very confusing to me. I don't have my chat window up. I don't think anybody has chatted, but just in case. Yeah, no chats. Yeah, why is that? I'd be really curious to know. Why is it doing that? IP route. Copy. 10. Okay. Now this still says not available. Look at that. Show run. Yeah, that's got to be something to do with viral here. Oh, 150, that's why. That's why this one is wrong. Yeah, now it's there. Okay, now our configuration is working. I have no idea why. Let me try to duplicate that problem. Let's just see if it comes back. So I'm going to lower this administrative distance from 10 to 0. I don't get it. It's inconsistent behavior. Strange. Okay. We will leave it at that. I'll write it off to viral inconsistencies, I guess. That's the only thing I can think of. Does seem kind of backwards to me still, the logic here. Why would it matter that this has a lower administrative distance? Okay, maybe that'll be in the lab key information. All right, so these are routed through the DMVPN cloud. We verify that if R4's V100 interface is disabled, that the traffic would go through T45. So basically, the only way that's going to come up is if this interface is down. Now that interface could be that means the physical interface would have to be down. So we should see, if we bring the interface down, we should see the keep alive time expire. Tunnel 45 should come up across this link, and that's where the traffic should go. So let's bring down the interface. Interface G01-100 shut. I have a couple tunnels here in play. All right, tunnel 45 changed to up there. Evaluate it down. Tunnel 45 changed state to up. Okay, so now let's check our loopbacks. 150.1.5.5. 155.45.0. Yes. Very good. Okay. It's a lot of noise there. So now trace route 150.1.4.4. Yep, it goes via VLAN 45. Good deal. All right, it's nice that the keep alive command is one command, which is really cool. So let's just clear our configurations here on router 4 and 5 and get ready for the next lab. Yes. No, yes. All right, those routers are reloading. We're going to, once they come back up, we'll reconfigure them. It's router 4. Router 5. Good deal. Now, lab 2, basic ODR, hub and spokes. Let's get water here. Thoughts on ODR? Well, essentially one, that it is not a dynamic routing protocol. It is a routing configuration that there are multiple topologies I read about that you can configure this on. But it uses CDP for advertisements, which I think is really cool. And there are some really practical uses for this. One I read about a lot is retail, where you have a large number of spokes and a single hub or a couple of hubs. In particular, where you're using a dial-up routing or dial-up interfaces, which hopefully there aren't as many of those anymore as there used to be. But I could still see where there might be some. So apparently I'm sure this is running in some places. And it's kind of a cool protocol. It's very low overhead protocol in terms of traffic and in terms of CPU, and it sounds like a really nice poor man's routing protocol. And that's what we're going to configure today. I'm curious to see what it looks like from the router. Like, obviously there's no show IP route, but you're going to have a route. It kind of reminds me of PBR, where you're going to have forwarding taking place on the router, where it's not using the traditional routing table that we think of. So that's going to be interesting. Let's get our no, our 4. Wednesdays I might get a nice TFTP set up here, but copy paste should work fine for now. Now this, we're going to need routers 1 through 5, which I think I have configured all of these. Yeah. Okay. They always whine when they first boot up. CPU hog, this and that, wah wah. Just boot up router. Let's get going. So and what I learned about this ODR too is that you do not configure it on the spokes, which just makes this even more non-traditional, the way I think of routing, even if it's on-demand routing. You only configure ODR on the hub, so this is real basic configuration, but it's going to be kind of fun to see what it looks like. It's not even asking us to change the timers here, although from what I was studying, there's a good guide on this, really good technology guide. It's kind of older, but it says that, essentially you can change the CDP timers in order to improve convergence, because CDP, I think, is on a 60-second cycle, by default. Show CDP. Yeah, sending CDP packets every 60 seconds. So, and there's a hold time of 180, which there's also a way on the hub that you can lengthen this hold time, especially if you have flappy links or, you know, a lot of unstable links out in a country store somewhere. You can extend this, I think, up to 250, 240, something like that. But anyway, link goes down, comes back up. It's not going to resend. The ODR is not going to re-advertise. It's going to cache that basically for even a longer period of time. And this is all just changing the CDP layer 2. That's another thing. This is a layer 2 protocol, leveraging layer 2 protocol. But let's go get right into it. We're going to be basically working on, routers 1 through 5. So we have to disable all these interfaces. We want hub spoke 1, 2, 3, 4, and 5. Yeah. So we're going to disable all the other interfaces except the DMVPN cloud. Yeah, so even this. So we're just going to have, just the cloud here, point to multi-point, and R5 is going to be these are going to be spokes, R5 will be the hub. So on router 1, that means show, let's see. I do not know what 0, 0 is, and I'm not going to worry about that right now. We're just going to do these. All physical interfaces. Well, it's a physical interface, so we'll shut it down. Interface G00, shut. Interface G01 through 113, shut. Interface G01, 146. Router 2. Same deal, fewer actually. Interface GI0123, shut. Yeah, we just want 0, 1, 100 up on these. To make sure. So yeah, only physical interface that is up is the sub interface. Okay. Okay, good. Router 3. Wait, 13, 23, I could have done a range, but wow, the thing's got a lot going on. Okay, that looks good. Router 4. Good deal. Now router 5, same kind of pattern here. GI0. Doesn't like that. It's 0145. Only wants a hyphen there? Okay. No commas? See, I knew there was a reason I wasn't using the range command. Okay. All right, we've done that step. Now we configure ODR on number 5. And let's check out. Had that ODR doc up here. Here it is. On-demand routing, and it's pretty simple. Router ODR. I think that's it. Oh, we have to check CDP. That's right. Show CDP neighbor. Let's just see if we have it here. Show CDP neighbor only on 0.1. Show CDP interface just 0.1 100. Yeah. Okay, router 2. Show CDP interface just 0.1 100. Up. CDP interface just 0.1 100. Okay. CDP is fat and happy. So configure ODR. Now, if it's running, cool, we do see ODR in here. So via ODR, yes, I have learned the loopback interfaces via 1, 2, 3, 4. Nice. Uh-oh, this is not correct. What's going on with router 4? Okay, I don't like how that looks, but there have been a delay there. 10.155.1. No, that's right. That's right, I think. No, that's not right. Show IP route. So I should have a route 150.1.0, 150.1.4.4. All the, I should have reachability to that. I'm definitely going to have it here. No, I don't. CDP enabled on these interfaces. So this is via DMVPN Cloud. Do I need to have CDP on the tunnel interfaces? No CDP entries displayed. So we've got ODR coming through. We've got some sort of received IPsec packet as invalid SPI for destination. Yeah, these are being learned via these other interfaces. 155.1.13. That, what link is that? .1.1.1. This link? That link is down. So how's that getting back to router 5? Oh, I bet I need to shut down the tunnel interfaces as well. That's probably screwing it up. Yep. Well, that's how I have my hub and spoke environment. Yeah, I can't tear that down. All right. See what I might be doing wrong here. Okay. I do have to enable it on the tunnels. So tunnel interfaces is not enabled by default. Yeah. It's probably why the ODR table was so confusing. That router was confused, man. Okay. Let's turn it off because I don't want to wait that long. No router ODR. Okay, I knew I needed CDP, but I missed that one step. We have to wait for it to cycle through to learn the other ones. I don't know where the heck I'm getting 172.16. Do I have to sort? I bet I have to source this from the loopback. Nada. What did I just do? I initiated a telnet session. Okay, I'm learning them, but it should not be via those interfaces. All right, that looks correct. Okay, so some sort of issue with the encapsulation of CDP over the tunnel. Okay, that's 53 seconds, so this should time out. And it did, but it's still sending it through the wrong. All right, let's do this. Let's disable CDP. At the interface level. No, I think it's just getting confused. All right, we did that. Let's see if it loses the route altogether. 47 seconds. $21, $25, $26. $15 more seconds. 12. Okay, so it still received a new. Port ID GI01. This is learned via tunnel 0, so do we need to shut it down? No, CDP enable. It's because of this viral topology. Hold time. Should start to, what is it, 180? Yeah, so there's a counting down. It's kind of cool to watch this behavior of CDP and these timers. All right, this is in single digits or double digits. Whee! Watching the countdown in the 80s. That's going to take a minute, but I'm liking what I'm seeing here now. If I do show CDP neighbor here, yeah, see now from R4 I'm getting tunnel 0. That should go away. You do it on these other routers too. Yeah. Nothing on tunnel 0 right now. Okay, interface GI 0, 1. Interface GI 0, 1, 100. Okay, it's up on tunnel 0. Not enabled. Okay, so nice. We can do it on the virtual interface. Ooh, countdown into the 20s. See if router 10 goes away here. 17. Hold time is 0. And then it goes away. Good. That's what we want. R1 should go away. And it does. Nice. Okay. Now, why doesn't it do it on router 1? Show, let's see. We need to configure router 5 first. Did we already? Show. Still sending CDP packets. Okay, interface is up 1, and that's tunnel 0. None. Yeah, theoretically I should be seeing is that because we have IPsec? Okay, R2 has come up. Every 60 seconds. Maybe it's just timing. All right, let's look at 2. Okay, interface is up 3. We need to change that. Okay, interface is up as 1. Good. Can't get your ODR to work without your CDP working. Okay, good. Now I can get to the loopback. So router 2 and router 4 are straight. So you can see ODR routes here. And it gets the default route. Awesome. Yeah, sweet. Okay, there's router 1. He took his sweet time. Yeah. Nice. Okay. So important takeaways, I guess. You could say show CDP interface. So in this case, needed tunnel interface. Okay. CDP must be operational. Tunnel interfaces do not have CDP by default. In case of a tunnel interface, must disable P on underlying interfaces. Good deal. Yeah, nice. Now, can they ping each other? They should be able to, because we have a default route. Yeah. Nice. Good stuff about ODR. Well, I think that wraps up the labs. Hit like or subscribe if you like these videos. If you want to come join live in the chat and interact, it'd be great. Maybe it would help you work on your labs too. So have a great weekend. I'll actually be streaming tomorrow though, and Sunday.